Okay, now we're recording. Okay, so this is number 14. Okay, add 19 to both sides. We get what? 55 equals 5t. Divide by 5 and you get t equals 11. How many of you got 11 on that one? You should have, because it's, yeah. Okay. Now, I'm going to take 11. What do I have to do with this 11? Plug it back in the equation to check for extraneous solution. So I'm going to go up here. 11 minus 3 is 8. So I get 9/8 equals, if I go 11 minus 4, I get 7. And 11 minus 3 is 8. And over here I have a 1/4, which if I'm going to add 7/8 to 1/4, I'm going to get a common denominator. I'm going to make that 2/8, right? And so 7/8 plus 2/8 makes 9/8, and I have 9/8 equal to 9/8, which means t equals 11 is a solution to this problem. And I don't have an extraneous solution. Yay. Okay? Any questions on this one? Kai? Okay. We're gonna do number 16 first, but since we're on the subject of Kai right now, Kai, come here. Okay, so this one right here, how many of you think you got the answer to this one? Okay, you guys got it? Okay. What? How many of you got help from everybody from my other class? All right. Okay. All right, on this one right here, there's a couple of tricks here. We got to figure out what the least common denominator is. We have a y plus 2 there, right? Let's skip over to this one right here. Y squared minus 4 factors to be y minus 2 times y plus 2. Remember, difference of 2 squares on that one. Okay, now I have a y plus 2. I have a y plus 2 over here and a y minus 2 right there. This one is kind of similar to it. 2 minus y, right?
Yes.
Okay, if I was to flip it, Sarah said that's going to be negative y plus 2. Is that the same? No. Okay. Let me show you a little trick right here. You can always factor a negative 1 out of any expression. And that's what we're going to do right here, because if I factor a negative 1 out of this expression, it changes that negative y to a positive y, and it changes that positive 2 to a negative y. And I have negative 1 times y minus 2. Now, I still have a y minus 2, but I have a y minus 2 kind of like that one. So I have a factor that works, but I still have a negative 1. But keep in mind, you guys, when you have a fraction that has a negative, it doesn't matter if the negative's out in front, or if it's on top, or if it's in the denominator like that. It's all the same thing. Right now, mine's in the denominator, right? So I could put it out in front, and notice I have this minus sign already. I have minus negative y over 2 minus y, right? It's a negative and a negative make. Think of it as multiplying. It makes a positive, right? So this is going to change to plus y over y minus 2. So let's rewrite this right here. We are going to have 2 over y plus 2 plus y over y minus 2. I factored out a negative 1, and it canceled with that right there to make it plus. So I have y over y minus 2 equals y squared plus 4 over y minus 2 times y plus 2. Okay, now, can I get my least common denominator from that? What is my least common denominator now? Y plus 2, y minus 2. So we're going to write that down. Least common denominator, y plus 2 times y minus 2. Okay. Okay, so I'm going to take, and I'm going to multiply each term, or each fraction, I can think of it each side, by the least common denominator. So I'm going to take y plus 2 times y minus 2, and I'm going to times it by the first fraction, 2 over y plus 2, plus, I'm going to times it by my least common denominator, y plus 2 times y minus 2, times by y over y minus 2, right? Equals, on your way, y plus 2 times y minus 2 times by y squared plus 4 over y minus 2 times y plus 2. Yeah. Actually, it leaves you with a nice equation. Yes, Sarah? They both cancel out. Nice. Your denominator should always, every single denominator should always cancel out if you times by the least common denominator, okay? So in this one right here, the y plus 2's cancel out, the y minus 2's here, and the y plus 2 with this y plus 2, and y minus 2 with that y minus 2. Okay? And what am I left with right here? 2 times y minus 2. If I distribute, what do I get? Okay. Plus y times y plus 2 is y squared plus 2y if I distribute. And then I'm left with just y squared plus 4 on the right side. This equation is quadratic as it's written because why? What makes it quadratic? Y squared. That's exactly right. So this problem becomes a lot easier. 2y minus 4 plus 2y equals 4. Okay? So 2y plus 2y is 4y minus 4 equals 4. That's a lot of 4's. Add 4 to both sides. What do we get? 4y equals 8. So y equals 2. What do we have to do with that 2? Plug it back in. Does anybody see a problem with this 2 if you plug it back in? Exactly. Good. Einstein. Right. Okay. Right here, you guys look in this one right here. If you put 2 back in here, 2 minus 2 is 0. Same with right here. 2 minus 2 is 0. It would be dividing by 0. And we know what dividing by 0 is undefined. Therefore, y equals 2 is an extraneous solution. Okay? So this one has an extraneous solution. All right. Now, I have one problem. Okay, I'm going to have 2 problems that we're going to work with on together. Go ahead, Sarah. Okay. Okay. I would like you guys, oh wait, here's how we're going to do it. We're going to do it as a sage and scribe. So we're going to do it. So what, I know you guys don't like this one's a good one though. One person in each group. Nope. Nope. I want to do a sage and scribe. I promise it's better. Okay, sage and scribe. One person in each group is going to be the sage. The other person is going to put down their pencil. And it has to be, well, the person with the pencil is a scribe. The other person is a sage. Scribe, you can't write anything down until the sage tells you what to write, unless they need a hint. Okay? Then you can give them a hint. Okay? Go. So you get W equals 3, W equals 1. So there's your 2 solutions. I would check for extraneous solutions. You should be able to see right off one of them's extraneous. Tyson. I'll come and look. Okay. All right. Are we done with that one? Are any of them extraneous? 1 is extraneous for sure, because 1 minus 1 is 0. We'd have 0 in the denominator. Are you saying 3 is also extraneous? Okay. 3 over 3 minus 1 is 3 halves, right? Plus 3 equals 4 times 3 is 12, minus 3 is 9. And 3 minus 1 is 2, so that's equal to 4.5. And 3 halves is 1.5, plus 3 is 4.5. 4.5 equals 4.5. 3 should work, okay? 1 does not. Okay. So that's how we got that. Stetson. There are some that both work. Sometimes neither one of them work. Sometimes one works and one doesn't. It just depends on the situation. Okay. This one right here, you guys. I'll tell you what, this one's going to end up quadratic as well when you're done. Okay, you should be able to see what the least common denominator is. Okay, 4n squared minus 2n squared is 2n squared. Plus the 6n equals 3n plus 9. Now remember, you guys, once again, this is a quadratic equation. I'm telling you what, almost everything that you guys are going to do in your math from here on out when it comes to do with these equations, it's going to boil down to 2 types of equations. Everything's going to be either linear or quadratic. The two problems I did that are on your assignment with you today, 14 and 16, they came out to be linear, right? Both of these problems we're doing as examples together have come out to be quadratic. You've got to learn how to solve quadratic equations. You either need to do it by factoring or by using the quadratic formula. One of those 2 ways. You need to know a way, and not every problem can be, not every quadratic can be solved by factoring. So you need to know the quadratic formula. Every single quadratic can be solved by using the quadratic formula. So we got to remember that. Okay, so to solve a quadratic, you always set one side equal to 0. So I have to minus 3n from both sides, and I'm going to get a plus 3n over here, and I minus 9 to get 2n squared plus 3n minus 9 equals 0. Okay, and then once I got you guys past the mistake you guys made by putting negative 6n right there, we got to here, and a lot of you guys couldn't remember how to factor it when there's a 2 in front of the n squared like this. Okay, we just need to find the factors of 2, which are 1 times 2. That's pretty easy. Find the factors of negative 9, which are negative 3 times 3, or negative 1 times 9, or 1 times negative 9. I have 3 choices right there. However, as small as 3 is, I'm pretty sure it's not 9 and 1. It's not one of those. I'm pretty sure it's negative 3 and 3. So I need to find a combination. I can either times 2 by negative 3 or 2 by positive 3. 2 times 3 is 6, and 1 times negative 3 is negative 3. And when I add those together, I get a positive 3, which is my middle term. So that's the one I want. Okay? So all you have to do is figure out what combination over here times by what combination over there is going to work. Okay, and then I set up my factors. I know I'm going to have 2n and 1n. And what number did I times 2 by? 3, not negative 3. So it's got to go in, so positive 3 has got to go in the opposite binomial of 2n. So I have a plus 3 there. That leaves me with a, a minus 3 right here. And there's my 2 factors. 2n minus 3 and n plus 3. I set each factor equal to 0. That's going to, and then I add 3, divide by 2, and I get 3 halves, which is the same thing as 1.5, and over here I get n equals negative 3. If I set that one equal to 0 and solve it. And there's my 2 answers. Now, could they be extraneous? Could one of them be extraneous, both of them? What? It's easy to see one of them. Look, up in the original problem, which one's extraneous for sure? Yeah, negative 3 is, because negative 3 plus 3 is 0 right here, and the denominator is 0, right? Okay, so that one's extraneous. If I put 1.5 back in there, or 3/2, okay, I could check that one. 3/2 times 3/2 is 9/4. And 9/4 minus 9 would be, I'd have to get a common denominator. 4 times 9 is 36, so it would be 36/4. So 9 minus 36/4. 9/4 minus 36/4 is 27/4. 27/4. You know what? It works. I can tell you that already. We don't want to go through the whole process. Okay, that one works. It might be easiest to put that one in your calculator and do it. It's 1.5. Okay. Huh? It does. We'll finish it. Okay. 3/2 squared would be 9/4. The 4's cancel out, so I get 9 over 27/4, right? Minus 2 times 3/2 is going to be 3. And 3/2 plus 3 is 4.5. And on the other side over here, I'm going to get 3 over 3/2 minus 3 is going to be negative 1.5 into 3 is negative 2, right? Is that right? I'm doing this in my head, so. Okay, over here, I'm going to have to simplify this. If I invert and multiply, that's going to come out to be 4/3 minus 3 over 4.5. And if I times this one by 3, top and bottom, I get 12/9. And this one, if I times by 2, top and bottom, I get 6/9. Whoops. 12/9 minus 6/9 is 6/9. I did something wrong.
No, you didn't. It just doesn't work.
It does. I did it earlier. It works. Okay. I made a mistake somewhere. That one's not extraneous, you guys. I just made a mistake somewhere here. Oh wait, if I invert and multiply, there's no inequality sign. 4 times 9 is 36 27ths. Oh, I know what I did wrong.
Nothing, because it doesn't work.
We're going to talk about systems of equations. You'll want to write this in your notes. Okay? You'll want to write this in your notes. Systems of equations. All right. Basically, a system of equations is 2 or more equations with the same variables. Some examples. Would be like 2x plus 3y equals 5 and negative 4x plus 7y equals negative 3. That would be an example of a system of equations. We have 2 equations. They both have the same variables, x and y in this case. Generally speaking, however many equations you have, not generally speaking, but for sure, if you want to be able to solve it, if you have 2 equations, you have to have 2 variables to solve it. If you have 3 equations, you have to have 3 variables to solve it. Okay? There are equations with more than 3 variables, but that is a class for college called linear algebra. Okay, so Einstein took it already. If you want to take that class, that was a class I took in college, fun class. I had this Chinese guy. I couldn't understand a word he said, but he was super smart. It was like watching. It's like watching the smartboard presentation and not hearing the sound. So, so anyway, that's how I had my class. It was frustrating. This was in college. This guy was super smart. I just couldn't hear anything he said. Okay, so that's an example of a system of equations. Now we can have like a quadratic equation and a different kind of equation. Maybe let's say absolute value equation. And that creates a system of equations because you have two equations, you have two variables. They don't have to be the same kind of equations. Like these two over here are linear. This one's quadratic, this one's an absolute value equation. Okay, you can have different kinds of equations. Okay. Do you remember what the solutions graphically are? Yes. Like if I graph both of these, can I look at the graph and tell about what the solutions are? Okay, let's list all the ways to solve. Ways to solve elimination. That's what I was asking, yeah. Ways to solve systems. Sorry, you said ways to solve systems. You guys learned substitution. You guys did learn that, right? I think in Segner Math 1. Elimination, you learned that way. You learned how to solve them by graphing. And the question I was asking is, do you know what, if you were to graph your two equations, do you know what you're looking for as the answer? And the answer is where they intersect, right? Okay, so where they intersect. One other way that someone actually mentioned in my other class that I don't think you guys have ever learned about is using matrices. A matrix, like a square array of numbers, okay? So there's different ways to solve those, okay? Another way is to use tables. You can look at tables, make an XY table, figure them out. Okay, these are different ways you can solve them. Now, yeah. Well, when you get more than, like when you get three equations and three variables, they have these methods called the row echelon method and things like that. But basically, it's basically using elimination and substitution, a combination of those two is what it is. So basically, this is it. This is the way you solve them. Okay. Now we're going to explore solving systems of equations by graphing. And we're going to use more than just two linear equations, because I think when you guys learned about this in secondary math 1, you just did two linear equations, right? We're going to study and look at different kinds of equations, like a quadratic with a absolute value, or an exponential and square root function. Okay, we're going to look at different kinds of functions, and we're going to use graphing calculator to do most of it, and tables on the graphing calculator. So we're going to graph them to do it, and we're going to use tables. So we'll be heading in that direction. Okay, now what I'd like to do, we're going to finish the class with a task. Okay, remember it's important when we do tasks that you guys do it together and try to understand what we're doing. We're going to do it in pairs. Okay, I'm going to have, Rebecca, will you come up and sit by Addie? And then you three are just going to have to work on this together, okay? All right, so we're going to hand out the task. You guys are going to finish the task in class. I expect you to finish in the last 20 minutes of class. And the next time you come to class, we'll be exploring these on the calculator a little bit more.